1/3 of all global trade squeezes through a single 112-mile stretch of water every day. This is the Taiwan Strait. And right now, engineers have a $12 billion plan to put a tunnel through the bottom of it. The Channel Tunnel, connecting Britain to France, took 13,000 workers and 7 years to build, and it's only 31 miles long. The Taiwan Tunnel would need to be 3.5 times longer. And that's not even the hard part. The Channel Tunnel sits in calm, stable rock, while the Taiwan Strait sits on top of an active tectonic collision zone where two of the Earth's plates are constantly grinding against each other. This is an earthquake country, typhoon country, the kind of seafloor that moves. In 1999, Taiwan was hit by the Chi earthquake, magnitude 7.6. It killed 2,400 people and moved sections of the island's surface by up to 8 meters. So when engineers look at the Taiwan Strait and say, let's build a tunnel through that, most of the world says, impossible. But in certain research labs and government planning offices in China, that word lands differently. In the last 20 years, China now operates the world's largest high-speed rail network, over 25,000 miles of track. That's more than the rest of the world combined. And a massive chunk of that network runs through mountains, under rivers, and beneath cities, all dug with tunnel boring machines, or TBMs. Think of a TBM as a mechanical earthworm the size of a skyscraper laid on its side. A spinning steel disc face, sometimes 50 feet across, that grinds through rock, scoops up the debris, and pushes precast concrete rings behind it to hold the walls. It moves slowly, sometimes just 50 to 30 feet per day, but it never stops. China now manufactures its own TBMs through a company called CRCHI, China Railway Engineering Equipment Group, one of the largest TBM manufacturers on Earth. They've used their machines to dig under rivers, through sand, through clay, and through granite mountains across dozens of major projects. China has completed multiple major rail tunnels under the Yangtze River, one of the most unpredictable waterways in Asia, on schedule and within budget, according to state-linked engineering reports. In Guangzhou, engineers successfully bored a subway tunnel just meters below existing underground structures without major incidents, a feat that would have seemed reckless just a decade earlier. These are real projects, real milestones, but the Taiwan Strait is a different beast entirely. The depth, the seismic instability, the sheer distance. Human crews working down there under 300 feet of water pressure in active earthquake zones would face catastrophic safety risks and logistical nightmares that could delay the project by decades. So the proposal goes further than anything done before. The plan is to keep the active drilling zone entirely machine-operated, with humans only in control centers on land. A conventional TBM has a team of engineers riding inside the machine, monitoring everything in real time: the pressure, the soil composition, the cutter wear, the ground movement. When something goes wrong, they make a call. But when you're 200 feet underwater in a seismic zone, can mean catastrophic flooding or structural collapse in minutes. The new generation of autonomous TBMs is being designed to replace that human judgment with sensor arrays and AI decision systems. Hundreds of vibration sensors, ground pressure monitors, and laser mapping tools would feed real-time data to an AI controller that adjusts drilling speed, cutter pressure, and grout injection automatically, in theory, faster and more consistently than a human crew could manage under those conditions. The cutter heads, the spinning steel discs that chew through rock, would be swapped out robotically. That used to be the most dangerous job in tunneling. Workers would enter a pressurized chamber at the front of the machine, sometimes in atmospheric pressures that could cause the bends if they surfaced too fast. With robotic arms and camera-guided systems, engineers aim to make that job happen without a single person in the chamber. For maintenance and inspection, remotely operated vehicles, essentially heavy-duty robots on wheels, would travel the completed sections of tunnel behind the machine, checking the concrete ring walls, injecting sealant into any microcracks, and transmitting data back to a control center that could be anywhere on Earth. AI-guided TBM control and sensor-driven grouting systems are genuinely being developed and tested. Similar robotic concepts already operate in advanced mining environments, but a fully autonomous, crew-free boring system running 112 miles underwater has not been demonstrated at this scale. This is where serious engineering ambition meets the edge of what's been proven, which makes the insurance calculation interesting. If it works, no human casualties in the active drilling zone means dramatically lower liability, lower safety delays, and lower political risk. A project that kills workers makes headlines that kill funding. A project where machines work in silence, underwater, in the dark, that's just an engineering problem. So where exactly would this tunnel go? Two proposed routes have been studied in Chinese planning circles since the 1990s. The most discussed runs from Fuzhou in Fujian province on China's southeast coast to Hsinchu in northern Taiwan. That distance is roughly 180 kilometers, or about 112 miles. The second option runs slightly further south from Xiamen to Taichung, using a small island called Pingtan as a midpoint way station. Pingtan already has road and rail connections to the Chinese mainland. The idea is to break the crossing into two shorter tunnels, with a surface rest point in the middle, similar to how the channel uses the UK and French coasts as anchor points. The strait floor drops to about 300 feet at its deepest, and at that depth, the water pressure on the tunnel walls is 10 times what you feel at sea level. Every concrete ring holding the tunnel together would need to be fitted with millimeter precision. One bad joint and the ocean comes in. Then there's the seabed's soft, water-soaked sand, the kind that doesn't warn you before it collapses. And beneath that sand, fractured granite. Not solid rock, broken rock, the kind that shifts from hard to soft without warning. That's where boring machines get stuck, and sometimes never come back out. Feasibility estimates put the job at 12 to 16 TBMs running simultaneously, a construction window of 10 to 15 years, and a price tag somewhere between $12 and $20 billion. Not a signed contract, just the honest best guess of engineers who've done the math. That's roughly what it costs to build a brand new international airport, except this one sits 300 feet underwater. From Taiwan's perspective, and of many analysts who track cross-strait relations, this tunnel is not infrastructure, it's a vulnerability. The government in Taipei has never approved, endorsed, or participated in any tunnel study. There is no political framework, no joint commission, no cross-strait agreement that would allow this project to move forward. It exists almost entirely in Chinese academic circles, state-linked planning documents, and long-term infrastructure visions connected to China's Belt and Road Initiative, the global program that has built ports, railways, and highways across 140 countries. And here's why Taiwan sees it that way. A tunnel that carries 300 kilometers, passenger trains could just as easily move military equipment and troops in a matter of hours. When you're an island whose primary strategic advantage is the water that separates you from a neighbor that claims you as its own territory, a tunnel is not a gift, it's a leash. The $12 to $20 billion cost estimate comes from independent engineering analysis, not an official government budget. This is a proposal, not a project. So what is China actually doing with this idea? Some analysts view it as a soft power signal, a message to the world, and to Taiwan specifically, that China has both the technology and the long-term intention to connect the island to the mainland. Whether the politics cooperate now or not, build the engineering case first. Wait for the political moment. Others see it differently. A tunnel means trade. Trade means both sides need each other. And when two sides need each other, war becomes too expensive to consider. History says both arguments can be right at the same time, which is exactly what makes this so complicated. In April 2024, a 74 magnitude earthquake, one of Taiwan's strongest in 25 years, buckled roads and triggered landslides across the island. Imagine that happening while a tunnel full of passengers sits 300 feet below the ocean. Modern tunnel design can handle earthquakes. The segmented concrete rings used in TBM tunneling flex with the ground instead of fighting it. Tokyo's subways have proven that. The Channel Tunnel was built with it in mind, but designed to survive and actually survive a 70.4 under 300 feet of water. Those are two very different things. Engineers suggest building pressurized emergency shelters every 25 kilometers inside the tunnel, underwater safe rooms where passengers could wait if a section became impassable. That alone adds hundreds of millions of dollars to the budget. Solvable? Probably. Most engineering problems are with enough money and enough time. The harder question was never about the geology. Is the world ready for this tunnel to exist? The Taiwan Strait Tunnel is not science fiction. The technology exists in principle. The routes have been mapped. Engineering problems have solutions. What it doesn't have is a shovel in the ground. It's a proposal, a serious one, but still a proposal. People said the same thing about the Channel Tunnel, the Three Gorges Dam, the Hong Kong-Zhuhai-Macau Bridge, 34 miles of open ocean, completed in 2018. All of them are impossible. Until they weren't. The Taiwan Strait Tunnel would be 3 times longer, deeper, and far more dangerous politically and geologically, which means it either never gets built, or the day it opens, it changes everything. Because this was never just a tunnel, it's a declaration, concrete and steel, about who controls the future of the Pacific. Somewhere right now, engineers are running simulations, testing machines, getting closer. The technology is almost ready. The question is the world ready? And while that question hangs over the Taiwan Strait, China has already answered it somewhere else. They built a machine that lifts entire ships over a mountain. Not a concept, not a proposal. Already built, already running. That's the next video.